Let's get started. My name is Yumin Chen, and I'm from Origin Lab Technical Support Team. So welcome to this webinar on time series analysis. Before the webinar, just let you know that during the webinar, if you have any questions, you can put it in the Q&A window. My colleague Isho will help to answer it. And the recording of this webinar will be available on the Origin Lab website early next week. Okay. So let's get started. So in this webinar, I'm going to cover a couple of topics. I will talk about the time series plotting in Origin and different methods to reorganize the time series data. And I will also cover the topics of time series decomposition, time series smoothing, as well as the modeling of time series. Okay, so now let's get started. Okay, so when we see a time series, the definition of time series data is a sequence of data points, typically measured as successive time, spaced at uniform time intervals. And the questions that can be addressed by time series analysis include the following. So we can extract or capture the trend and the seasonality of a time series. For example, we want to know the trend of the production of a company or the temperature change over the years. And we can also use time series to do modeling and forecasting. We can use the historical data to build a time series model, and then we use the model for forecasting. And we can also use time series to do the causal relationships analysis. So for example, we want to know whether there's a correlation between two time series and by how many time lags. Okay, and we also want to use time series for anomaly detection. So this is more common in industry. People may want to find any outliers in the industry process, and we have a nice app called a statistical process control. And we have this contains multiple control charts that helps user to find the anomaly or the outliers of the process. Okay. I also want to mention that in Origin 2025, we add the menu item time series. Okay, so let me quickly show you. So it's under the statistics menu in a time series. So this just helps the user to quick access the time series graph tools and also the analysis tools. Okay, so just list the time series tools in this menu. Okay, just so you know, this is new. This is new in Origin 2025. Okay, okay. Now let's go to each topics. First of all, as I mentioned, that time series means that the data has to be recorded in a uniformly time intervals. But sometimes when we measure the data, they are not recorded in the regular time intervals. So if I simply hover over the sparkle lines of the time stamps, we see it's not like a linear or straight curve. So in this case, we need to do some transformation of the time series. Basically, we need to can do resampling of the data set, or we can do interpolation to transform the data set into a uniform time series. So in Origin, we can do that by using the interpolation tool. So let me quickly show you. I highlight the measurements column, and then I go to the analysis, mathematics, and I just use the interpolate, extrapolate. Okay. So the nice thing about this tool is you can specify the time intervals. So I set an increment of time. For example, I want to increment the time by maybe 2, and let's set the start to be 0 and the end of the time to be maybe 300. Okay. Yeah, if I click, yeah, I can also, let me see. Okay, for the output, I can click this triangle, say I want to output it into a new XY values. Okay. If I click OK, then I have a new column of timestamps, which are obviously uniform and a new measurements. Okay, so I can turn on the spark line. Like you can quickly tell. Okay, yeah, if I just plot out these two columns as a line plot, yeah, they are, of course, just 100% overlapping. Okay, so this is a way to do transformation to convert irregular time series into a regular time series. Okay. Now let's check some of the time series plot in Origin. So here I have this data set. It's a measurements uh, of the each day. Okay, it's a daily data set. And I have another column which I calculate the year value of each timestamp. Okay, so let's start with the time series explorer. As I said, you can get access to this graph template by simply going to Statistics, Time Series, Time Series Explorer. But if you are using Origin version before 2025, you have to go to the Plot menu and then go to the uh, Extended Template Center. Okay. Yeah, so just search for the time series, let's say. Then you'll find this template called Time Series Explorer and click the button to install it. Okay, so let me just start the graph template. I highlight column B, then go to Statistics and go to Time Series and let's say Time Series Explorer. Okay, by default, it shows the entire time series in the bottom panel, and you can just move the window, resize the window and move the window around to check different section of the time series. Or you can go click this button and say, I want to check the time series in 6 months time interval. Okay, then I can move it around and I can also, let's say, click this left and right button to move the window left and or right. Okay, then I can also click this button to say I want to display the change of the windows as a video. Okay, so this is a tool that you can quickly scale in to check the portion of your time series. Okay, this is one plot option in Origin. Another one is the time series plot. Okay, um, let me go to the statistics and find the time series and the time series. It's the plot template is under this time series analysis app. Okay, if I click that, it opens up a time series analysis app. Okay, if you are working with old Origin, you can go to the App Center. Okay, and click the Add Apps button to search for the time series and add the app into your collection. So here I have this time series analysis app already installed. If I click that, it also open up this dialog. Yeah, just to mention that if you want to check the help documentation of this app, you can simply click the question mark and it gives you all the detailed like the tutorials and the algorithms of each tool and a graph template. Okay. Okay, let's go to the time series plot, and I will choose with grouping. So here I have the input data already set as column B, and I can check the auto preview to check the graph. And for the group column, let me just choose the year. Okay. So, and I can also apply a smooth. So I apply this local weight scatter plot smoothing method, and you can specify the window size of the smoothing. Yeah, of course, if you set a small value, then it's less smooth. If you apply a larger value, it's getting the curves more smoothed. Okay. So Origin has many other smoothing tools for time series, and I will show those later on. Okay, so let's say I can simply click OK to generate this time series plot, and in the object manager, if you want to just check the trend of the time series, you can turn off the scatter plot. Okay. Yeah, so this is another option to make a time series plotting in Origin. Okay, so let's move on. In the previous example, I showed you the two graph types in Origin. But sometimes people, instead of just looking at the entire time series, they may want to compare time series in short time intervals. For example, here I have this uh, daily data, but they want to compare the curve between the different years. So here we have this tool called unstack by time intervals. So I can split long-term time series into small segments. Okay. Here, let's say I have this again the daily data from year 1905 all the way to 2024. Okay. Let's use this tool to split the long time series into small intervals. Okay. I will highlight column B, and yeah, you can get the tool from the stats time series unstack by time interval, or you can go to the restructure and unstack by time interval. Okay, both will open the same um, tool. Okay, so here, let's say I want to just split the data by year. Okay, so I just choose year here. Okay, let's start with this setting. Okay, so now you see the data for each year are being put into a separate columns. Okay, now if I want to compare the time series for each year, I will use this graph template called the browser graph. Let me just highlight all columns. Then I will just go to the plot menu and go to the browser and find this. Yeah, this time I will use the stack lines graph template. Yeah, let me choose that. Okay, so on the left-hand side, it just lists all the columns in this worksheet, but by default, it shows the short name. I would like to change that to the year, so it's more informative. So let me right-click and say year, and I can turn off the short name. Okay, so this way, I can pick year from the left-hand side, and it will plot out the time series for it for the corresponding year. I can also just click on the legend and say I want to put the legend to the side of each curve. Okay. Um, so this way, some other options like you can select multiple curves. Okay. Then I can do flip through. Okay. I can move the year 5 years at a time. You just click that. Yeah, so this way you can quickly compare the patterns of the time series of every 5 years. Uh, some other option is like you can, for example, select every, let's say, 20 years. Okay, and can also do a flip through. Okay, yeah. So this is a option in Origin that you basically split the long time series into short segments, then um, compare them. Um, so here I just compare the data of each year from January all the way to the December. I can click this green lock, say I'll change parameters. I can specify a certain month range for comparison. Let's say I want to compare the data from September to December, let's say. Yeah, it will only show the um, data from September to the December. I can rescale it. Okay. Yeah, just so you know that if you want to change the settings in the tool, you basically click the green lock and change parameters and to make a change. Okay. Okay, so this is unstack data by time interval tool. Let's go to the next topic, aggregate time series. Um, Sometimes user have this daily data, but you can definitely use the daily time series data for modeling, but it has some issues. For example, maybe there are many noises within the data caused by the daily variation. So you may want to, aggregate the daily data into monthly data or yearly data. There might also be some missing data within the time series. You want to aggregate that, to replace the daily data with the monthly data of the mean value or the sum of the daily data. So in Origin, we introduced this new tool called time series pivot, which is also new in 2025 for this purpose. Okay, this let me quickly show you. So here I have this data set of the Logan Airport temperature from year 1970 all the way to 2023. Okay, this is the daily data. So if I want to aggregate the data into monthly data or yearly data, let me just highlight the measurements uh, for the transformation. Then I go to this restructure and time series pivot. Okay, I just choose this tool. Here, okay, let's first aggregate interval. Let me choose month. I want to aggregate by month. Okay, so you see here the year is automatically specified as a time period. Let's just keep the settings as it is. Okay, so here it will just uh, convert data into monthly data organized by rows. Okay, so let me click OK. It just calculates the mean value uh, of the of the data in for each month and across all years. Okay, so it has the entire mean value for each month being calculated. Um, so something we can do is uh, instead of just looking at the mean value, if you wanna check other statistics, I can click this button and say change parameters, and here go all the way down. So by default, it's aggregated by mean. If I click that and say custom, I can add a mean value, standard deviation as well. Let's say I want to add the mean value and also the max value, okay, of each time interval. Okay, so now I have more statistics here. So I can quickly highlight all of them and just make a scatter uh, and a line plot. Yeah, quickly we can check the trend of the temperature goes up from February to all the way to the July, then going down to the December. Okay. Okay, let's turn this off. Okay, so let me make some changes to the setting. Click the green lock, change parameters. Okay, I will turn off the custom and just still show the mean value. And this time I will just turn off the year. Okay, just click OK. Then it will just aggregate the daily measurements into a monthly value. So each month, the value for each month is the mean of the daily data of that month. Um, so it still like it has the two many data set data points. So for example, I can just analyze the data within a certain time period. Let's say I want to just check the data from 1970 to 1980. Okay, I can click this green lock and say, yeah, the settings here. So I want to say 1970 to 1980. Okay. Yes, if I just scroll down. So the data will go all the way to 1980. And I can click the column and turn on the spark line. Okay. Yeah. So with the monthly data, we can see it's much smooth now. Okay. So this is the one type of organization of the data set. So what if we want to put the year values to each column? Okay, so that we want to reorganize the data set. Can click the green lock, change parameters. So this time I will add year to the columns aggregation interval. Okay, like just put a year here. Yeah, you see here the year is also automatically set for time period. Okay, yeah, click OK. So this way, just reorganize the data. So the year value is on the column header row and the month is on the first column. I can use this data to, for example, make a heat map. Okay, go to plot, go to the contour, then just do where it is heat map here. Okay, X across the comments, that's good. The Y value in first column in selection. If I click OK, yeah. So this way you can just examine the data. Again, for each year, the temperature goes up from January to July, then goes down to December. And you can also check whether there is a temperature change along the year direction. Yeah, not obvious here. Okay. Okay, so here is like we separate the data, aggregate data by months on the rows and by year on the columns. I can do another change. So let me click green lock, change parameter. So this time I will just aggregate interval by decades for rows and aggregate interval as months for columns. Okay, let's quickly check how the graph looks like. Um, I can do all years, so I just turn off the from and to value, click OK. So it gives me the temperature, mean temperature of each decades and of each month. Okay, so let's say let me just um, check the mean temperature of the winter month, let's say January, February, and December. Okay, and plot out a scatter line symbol plot. Okay, so you can just examine the temperature change along the years for the winter months. Okay, so maybe there is a increasing trend, right? Okay. Yeah, so this is an example of using time series pivot to organize data, making graphs, and explore the time series data. Okay, so I think this is all about the graphings and the organization of time series. Let's move to the time series analysis. Okay, before doing any analysis, just here I have this. Just quickly show that what times a general time series will look like. So on the top here is the data of a time series. So most of the time, the time series contains three components: the trend, okay, which is the long-term movement or change of the time values of the measurements, and also the seasonal components, which shows the periodic um, variation of the measurements. Okay, and the last one is the remainder or the noise of the data set. Okay, so the question we want to answer using the time series analysis is to first is to find the trend of the time series and also to decompose a time series into different components. Okay, so here in Origin we also have a couple of tools for each purpose. So let's first start with the time series decomposition. Okay, so when we try to find the trend, the trend can of different types. So some of the trend may is follow a certain maybe curve which can be fitted with the fitting function. For example, like the growth of the revenue of a company then can follow a uh, linear straight line, or the population of a country may grow exponentially, then you can fit that time series with the exponential in growth function. Okay, so here I show two examples where the trend is well defined and can be fitted with the curve. So let's see. So here I have two data sets. By just looking at the spark line, we can tell that one data set has this trend going up, but it doesn't have the seasonality. Okay, the other data set we have this uptrend and also the periodic seasonality feature. Okay, let's start with the first one. Um, for this kind of data set, we can use the trend analysis tool. So I start the time series analysis app. Let me go to the trend transform and decomposition. So trend analysis. Okay. Um, so the column 2 is the time series, and time label. I will just use column A, which is a time value. I can turn on the auto preview. Okay. Yeah, so this tool is simple. It's nothing but just fitting a curve, fitting a function to the curve. So for the model type, we can use there are four fitting curve that you can use: linear, quadratic, exponential growth, logistic. Let me just choose quadratic. Okay, and I can also use this to do for forecasting. Number of forecasts. Yeah, let's say 10. So we just forecast the 10 values in the future. Okay, quantities. There are the fitted values, whether the fitted parameters are significant, different from zero, things like that. And fit statistics tells you the goodness of the fitting. Okay, and plots, output. Yeah, just click OK. So here we use a quadratic function. So it's the function expression with the fitted parameter shows here. And by looking at the p-value, they are all below 0.05, which tells that the fitting function is appropriate for this trend. Okay. Okay. So this is the um, trend analysis for the time series. Let's check another example. So in this case, I have seasonality. So instead of using the trend analysis, I need to use a different tool called decomposition. Okay. Again, let me highlight column B and go to the time series analysis app, decomposition. Okay, let me make it bigger. Okay, the time series column 2 and time label the column 1, and go to the settings. Okay, so the to use the decomposition tool, I have to tell the seasonal length, so like the period of the time series. Yeah, okay. So here I have this monthly data. Okay, we can guess the seasonality length should be 12, but I can double click the spark line and just highlight. Sorry, just hover the mouse on the data point to tell. So it's a row 32. The index is 32. And if I move to the next peak, the 44, so the difference is 12, so which just confirm our guess, right? Okay, so let's go back to the tool. Okay, so for the settings, seasonal length, I will just set it to 12. Let me turn on the auto preview. And also here the model type, so multiplicative or additive. If the amplitude of the seasonality goes up with the trend, then we will use the multiplicative. If the amplitude of the seasonal measurements stays the same, then we use the additive. So yeah, we can quickly check. If I choose additive, you see the amplitude of the seasonality didn't change. So, but obviously in this case, we will use a multiplicative model. Okay. And yeah, we have both trend and the seasonality. So I just check this one. Yeah, I can also do forecasting because this is the monthly data. I can do like 24 months ahead. Okay, so it also shows the forecasted values. So other quantities is like, yeah, this is similar. The fitted parameters, information, goodness of fit statistics, and also it gives us the analysis of the decomposed data set. We will check. Okay. Yeah, let me click OK. Okay. So other than these um, results, we also has this component analysis graphs. So it gives me the original data and the detrend data. So the trend is removed from the original data. Then I obtain this curve. And the seasonality data, if I remove the seasonality from the original curve, so it's more like the trend, okay? And also the residue, okay? And also the seasonal analysis, it gives us the quantities of each month, okay? Like the variation of the measurements, the magnitude of the measurements, how it changed within each year. Okay. Okay, so this is the decomposition tool. Okay, now let's go to the next topic, smoothing. When we get a time series data and want to do smoothing, the first thing we can think of is the moving average. So um, if I let's say start with the data time series, and yeah, we also have the moving average smoothing tool in the time series analysis app. Yeah, we go to smooth moving average. So basically, it's just calculate the smooth the value of each data point by averaging the local or neighboring points of that timestamp. Um, yeah, so basically you need to specify a window of the moving range. Yeah, so set it to a larger value will apply more smoothing to the time series, which is makes sense. Yeah, so it's just the most general moving averaging tool or smoothing tool for the time series. But we can do better. So what if I wanna, because this is a time series, I would like to put more weight to more recent data points for the smoothing. Okay, so here now we have the three uh, exponential smoothing methods, the single exponential methods, double exponential method, smoothing methods, and the Winters methods. So which method do we use depends on the characteristics of each time series. If the time series only doesn't contain the trend and the seasonality, we will use a single exponential smoothing. In which case, we just if you look at the expression here, we just model the level of each time stamp by the current value and the level of the previous one time step. So here I need to apply a weight alpha here. So the alpha is the parameter need to be fitted in this model. Okay, then the predicted the smoother value of the current timestamp is just the level of the one time before. Okay, so you can see that um, the weight of the previous y is decreasing exponentially. So that's why it's called the single exponential smoothing method. So if the data set has not just has a trend but doesn't have the seasonality, we'll use a double exponential smoothing, where we need to fit two parameters, which corresponds to the level and another corresponds to the trend. Okay. Again, if the data set has the seasonality, okay, then we will add another fitting parameters. So it's more complicated model to fit both the level, trend, and the seasonality. I will show each one of it quickly. Start with a single exponential smoothing model for the most general time series. Okay, let's go to the time series analysis, single exponential smoothing. Turn on the preview. So here, the smoothing constant, which is the alpha value to be uh, fitted, so which is the weight of the first neighboring y value. Okay, you can specify the value. If you specify a bigger value, it just apply less smoothing because the current y is more close to the most recent y values. And you can also apply, if you check the auto, Origin will apply a ARIMA model to the time series and automatically calculate the smoothing constant here. Okay, so you can specify a number of forecasting, let's say 10. Okay, it also gives us the confidence interval for the forecasted values. Okay, let me click OK. Yeah, we can quickly check the result. The alpha value is specified by the ARIMA model and the goodness of fit statistics and also the graphs. Okay, this is for the single exponential smoothing. So let's see the next one is the double exponential smoothing. So again, I specify the input data. Yeah, let's just turn that back to the default. Okay. So under the setting, this time I need to specify two fitting parameters, level weight, trend, and you can also say I want to calculate that by the optimal ARIMA. Okay, I need to turn on the auto preview. Okay, so you can check the fitted curve on top of the data, and I turn on the forecasting. Again, let's do 20. Okay, yeah, let's click OK. Two parameters are fitted. Okay, let's quickly check the Winters method. So here I have this um, periodic data. So check the difference between the peak to tell the seasonality length. Again, it's a 12. Okay. Let me turn on the Winters method. Auto preview. Turn on the auto preview. Timestamp is called an A. Settings. Okay. Seasonal length. Yeah, I confirm that's 12. So whether it's a multiplicative model or additive model, so we can tell the amplitude of the seasonality didn't change much over time. So I will check the additive model, and here I can specify the level weight. So you just tune the parameter. So this there's no way for this tool to automatically calculate those parameters. So I just use some of the values, and maybe this is a good fit. Okay. Then I can do a forecasting. Let's say number of forecast is 24 again. So 12, 4 months ahead of time. Okay. Yeah, so let me click OK. Okay. Yeah, so let's this is the exponential smoothing. But one drawback of this the smoothing method you can tell is that you have to determine the parameters by yourself, or you choose the ARIMA model for the fitting. Okay. Okay, now let's move to the ARIMA model. Let's start with non-seasonal ARIMA model, then we go to a seasonal ARIMA model. So let's say ARIMA here stands for the autoregressive integrated moving average model. So it has three orders that we need to determine before running the model. So the first is the order for the autoregressive model, and the Q is the order for the moving average model, and also the order of the differencing. So for a ARIMA model, the time series needs to be stationary. If it's not, then we need to do differencing. Okay, so the D here means the degree of the differencing before running the model. Okay, so let's say I have this time series. It doesn't have a seasonality by just looking at the curve. Okay, let's first do a stationary test, see whether we need to do a differencing before running the model. Okay, let's go to the time series analysis and go to the statistics and testing, then stationary test. So here, um, yeah, I just click this and say I want to check whether there's a constant and trend. Okay, let me click OK. Yep, I just read the footnote here. It says the time series is stationary, uh, so that we know that the order D here is 0. Okay, we can determine that. Then we need to determine the P and the Q. So for that, we need to use the autocorrelation function plot and the partial autocorrelation function plot to determine that. We also have that tool in Origin. So it's a ACF and a PACF. Okay, just click that. Just make sure to check the partial autocorrelation box. Okay, let me click OK. Okay, so let's see. So from the ACF plot, we can see the spikes probably follows exponential decay and also fluctuating shape. So we can determine the Q value, or the moving average order here is 0. And if we look at the PACF plot, so we can tell that there are three big spikes at the beginning, but followed by small spikes. So if this is the case, then we can determine the order of the autoregressive model, or the P here, to be 3. Okay. Then yeah, this is a way to determine the order of the ARIMA model. So now if we set P to 3, then we have 3, 5 values to be fitted, and uh, yeah, just the 3 parameters in the model. Okay. Let's then use the ARIMA model for the fitting. Okay. Go to ARIMA, then go to select the model. Okay. Let me just set it to system default. Turn on the auto preview. Go to the model. So we determine the model to be P equals 3 and the difference 0 and the moving average 0. Okay, 3, 0, 0. And the fit seasonal model, no, because we don't see a seasonality. Okay. And we can also do uh, fit data. Yeah, we can output the fit data as well. Number of forecasts. Yeah, let's say 24. Okay, graphs, outputs. Okay, let's just click OK. So in this report sheet, one thing we can tell is if we just look at the parameters, we the order of the the autoregressive model is 3. So we fit the 3 values. Uh, the p-values of all of them are below 0.05, so we can tell um, uh, the 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 3 parameters are significant. Okay. Yeah, if you want to change this model, you can click the green lock. Let's say if I say I want to add one order to the autoregressive. Yeah, but this way you can tell that the fourth order p-value is above 0.05. It's not significant, then it can be removed from the model. Okay. Okay, now let's move to the seasonal ARIMA model. Okay, here, yeah, if we look at the expression here, other than the original ARIMA model, we need to add another three orders for the seasonal components of the ARIMA model. And we also, the small m here is the seasonal length. Okay. Yeah, so this is again, has this, the seasonal length here is 12. So the curve repeats every 12 months. Okay. Um, so we know that for seasonal data, it's not stationary, of course, because the variation or the mean value of the season data does change over time. So we need to do a seasonal differencing before. Okay, we can do the differencing using let's see, transform and decompose differences. Okay, so here make sure to check the seasonal difference. Just need to remove the seasonal difference before we do a stationary test. Okay. So let's start with 1 and a period of 12. Okay. Click OK. And yeah, I can turn off the sparkle line. Okay, then I can use this data after differencing for a stationary test. Okay. Let's go to the time series analysis. Again, go to statics and the test and the season stationary test. Click OK. Okay, it says at 0.05 level, the time series is stationary, which means we don't need to do the normal differencing. So after the seasonal differencing, the data is stationary already. So this way we can tell the capital D order is 1 and the small d order is 0. Okay. Then again, quickly just use the ACF and the PACF to determine other orders. Okay. Yeah, let me quickly click OK. Yeah. So again, we see a exponential decay of the spikes. So we can tell the MA order is Q here, small q here is 0. And we still see 3 spikes for the PAC curve, which means the small p-value is 3. Okay, so it's a 300 model for the normal ARIMA. And for the seasonal ARIMA, we just, yeah, let me turn this on. We have, if we check the seasonal spikes here, yeah, I see one at 12/1 period, another one at 24. So another, so after that, I don't see any significant spikes at 36, right? So I can determine the capital P or the seasonal autoaggressive order is 2 in this case, and we did a seasonal differencing, so the capital D is 1. Okay, so now we determine the order. So in this model, we have 3, 2, 1, 6 parameters to fit. Okay, then I can go back to the original data. Let's run the ARIMA. Yeah, just quickly do that. Okay, so let's go to the model. So this time the autoregress, the general ARIMA model is 300, and we need to check the seasonal model, and the period is 12, and autoregressive is 2, and the difference is 1. Okay. Yeah, it also already shows the forecasted curve, which is nice. Okay, click OK. Okay, so again, we can check the p-value of the fitted parameters. Okay. Yeah, so this is using a ARIMA model to do the fitting and the forecasting. There's still some time left. I will just talk a little about the cross correlation. Assume I have two time series. I want to check whether there's a correlation between two time series, and also I want to know how many time lags between the two. Okay, so let's say I just yeah, let me start the tool first. Go to the time series analysis. It's under the statistics and test cross correlation. So the first time series is column B, and the second is column C. Okay. Yeah, by just looking at the cross correlation plot, we can tell that at a lag of 2, the correlation is the strongest. Okay. If I click OK, then it generates the plot. Okay. So if the column B is the probably maybe the money to be spent for the advertisement, and the column C is the income of the revenue. Maybe there are, if we look at this plot, we can tell there's after 2 months of the investment, we can see the effect, right? Okay, so this is the cross correlation plot. Here's another example. Okay, let's start doing the cross correlation with the column B and column C. Yeah, so this data doesn't work very well. We see the cross correlation for all the lags. So the reason of that is because the time series itself has autocorrelation. So the 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 time series is correlated with the history of this series, because these two data sets I simulated them using the ARIMA 110 model. So it contains the autocorrelation. We need to remove the autocorrelation first before running the cross correlation. Okay, so to do that, we need to use a pre-written method. Okay, so let me just highlight these two time series and go to the ARIMA. So we have this pre-whitening tool. Yeah, this is I know this is from the ARIMA 110 model. So I just type 110 here, and then I just click OK to for the analysis. Okay, I have this pre-written data. Okay, then I can use this data set for cross correlation analysis. So here's some missing data. I will just hide the two values before I run the cross correlation. Again, go to statistics and test cross correlation. Yeah, so this time I see a strong spike at a lag of 1, 2, 3, 4. Okay. Yeah, so this result makes more sense. Okay. Okay. Okay, so I think this is pretty much I want to cover for this webinar. I hope you will find it useful for you to do time series analysis using Origin. Thank you for your time and patience, and have a nice day.